Hi everyone, welcome to SIG Apps. It's June 19th. If you could, if you're not speaking, just mute yourself, please. My name is Michelle. Dan's going to take our notes for today. Thank you, Dan. We have a few announcements. I think the most important thing on the table is the Kubernetes 1.7 updates and progress. So, Dan, do you have anything for us there? Take it away. Can't hear you.
Oh, dang.
Dan, are you talking? Because we can't hear you. Oh, okay. Let me work on this for a few minutes. Cool. That's fine. Thank you. And so we'll just go right into demos, and then we'll go back to Kubernetes 1.7. And first up, we have Aaron. He is going to do a service broker demo. And Aaron's from Microsoft.
Cool. Thanks, Michelle. Thank everyone for having me. I've been to a couple of these meetings, but not enough, sadly. So I'm really excited to be here. As Michelle said, I'm Aaron Schlesinger. I'm a colleague of hers. I work at Microsoft and formerly Deus. And I am a co-lead on the SIG Service Catalog Special Interest Group. So as Michelle also mentioned, we're working on the project called Service Catalog. You can check it out at Kubernetes Incubator. And the point of this thing is to connect Kubernetes with open service brokers. You might also know open service brokers as Cloud Foundry brokers. And these are things, these are REST API servers written in any language that adhere to a fairly simple specification. So there are a few important operations of these brokers. There's provision, bind, and get the catalog. Those are basically the three big things that we're going to need to focus on today, and you're going to need to sort of be familiar with. So get the catalog is fairly straightforward. It just gets the list of things that the broker can provide. And you'll probably notice some common brokers. You may have noticed them already. These are things like a broker for AWS or a broker for Google Cloud. More specifically, it might be a broker that can provision S3 buckets or can provision Google Cloud SQL databases. The demo I'm going to show today, of course, since I work at Microsoft, it's going to show provisioning Azure SQL Postgres databases. So I actually have a few slides. I'm going to share my screen. Don't worry, it's not going to be too painful. Most of this will be demo. So let me go and try to share my screen here. And can anybody not see this? Can you speak up if you can't see this? Okay, I'll take that as we're all good. Let me try and make this a little bit better. All right. So yeah, as I mentioned, this is the intro slide. So the way that I look at Service Catalog comes from basically this knowledge. Anyone who runs stuff in Kubernetes, or almost anyone, probably knows that just running a bunch of pods either isn't enough, or you have to do a lot of work to get other things in your cluster to do work for you. These are things that come to mind, like data storage systems or queues, maybe even caches. And a lot of apps rely on either software as a service offerings, or if you're a larger organization, other teams. So you might rely on AWS or Azure or Google Cloud or something else. Or you might even rely on another team to provide you with that Cassandra cluster or that Redis or whatever else it might be, Kafka, et cetera, et cetera. Let me try to advance this slide. So in essence, your app takes on service dependencies. And these are more than just like your app is a Ruby app and it relies on this Ruby gem. But in a distributed system, it's more like your app talks over the network to that Postgres instance. And by providing a Kubernetes native API to provision those services, so that's to create a new instance of a service and then to bind to that service. And that is to say, to indicate your intent to use that new instance of the service. This service catalog project enables you, the app developer, to essentially tell your operations team, or at least the person or people that are responsible for maintaining these services, whether they're in the cluster or on a SaaS platform, to tell them your intent that you, the application, are going to consume that resource. So with that, we are building, we're currently in alpha, we're building a system that sits on top of Kubernetes that looks a whole hell of a lot like Kubernetes. But it provides these 4 resources, and I've kind of touched on them. So instead of having pods and services and so forth, instead we have brokers, that's one, service classes, instances, and bindings. So I will explain those in the demo that's coming up right after the slide. But essentially, this is something that looks like Kubernetes, and in fact, you can talk to it with kubectl. And even better, in 1.7, Michelle mentioned some upcoming features. In 1.7, this thing will be an aggregated server. So you will actually use kubectl to create new bindings and new brokers and so on and so forth. And even better, you'll be able to put those things into a Helm chart. And I'll touch on that a little bit more and better in a second. And then the last piece here I mentioned is that this thing connects your Kubernetes cluster to brokers. And the brokers conform to this thing that I mentioned called the Open Service Broker API. So if you look in the bottom left-hand corner there, you can see the URL. You can go check out the spec and some details on the project and so on and so forth. This, in addition to being a spec, is also a working group that's responsible for developing, standardizing, and then advancing this API into the future. So they've started with a Cloud Foundry basic API, and now they're kind of going forward. And I'm also a member of that working group. So we're kind of talking about 2 sides of the system. There's the Kubernetes side, and then there's also the API side that's not really related to Kubernetes, but of course is very important to the Kubernetes effort. So let me shut down this PowerPoint slide, and let me go into a demo. So first and foremost, you can go check out this repo, and I'll provide these slides shortly after I do the demo, so you guys can go save it or check it out or whatever. But if you have a second, you can head over here. It's GitHub/ARSCHLES, and then Meta Azure Service Broker Helm. So I'm just going to be doing a demo straight out of the README. So let me open up my terminal. I'm going to make this nice and big. Can anybody not see this? Speak up if you can't see this.
It's good.
Okay, great. Okay, so I'm going to be using kubectl to talk to the service broker. So first things first, let me show you what I have installed in my cluster. So this is an Azure Container Service Kubernetes cluster. I have installed 2 apps. The first one is called Catalog, and that is the service catalog software. So that, again, is the thing that connects my kubectl commands with the broker, and the broker is called MASB. So that's called the Meta Azure Service Broker. And this is just something, again, that conforms to that broker API. And it provides me, as I'll show in a second, with access to a bunch of different Azure services. So the first thing I did, and I actually preceded this demo with a few steps that generally take a long time. I don't want to have you guys waiting here for 5 minutes or 10 minutes for something to spin up. So I did that stuff beforehand. So first things first, I have installed a broker resource. So there's the broker resource. This is not, by the way, a third-party resource. This is a resource that is provided by the catalog API server. So you'll notice here, I'm running I think I'm running a 161 cluster right now. So I've specified a new context. And this context points to a new cluster, quote unquote cluster, that speaks the same OpenAPI spec that kubectl expects. So this thing, like I said, it looks a lot like a Kubernetes clusters API, and therefore kubectl can talk to it. So you'll see that all my kubectl commands are going to end up using this context. And this is something that's going to be going away in 1.7 and beyond, because we'll be able to use aggregated APIs for it. So that's the first thing I did, was I created a broker. Now, after I had created the broker, Service Catalog picked it up. So Service Catalog has an API server and a controller, similar architecture that you see in Kubernetes Core. So when I created the broker, the controller in Service Catalog picked it up, made that catalog request out to the backing Meta Azure Service Broker server. And after the catalog came back, it converted that response into a bunch of things called service classes. So let me show those. So here we have essentially the catalog of services that I can provision and bind to, and essentially I can get to use in my app. So DocumentDB is the NoSQL storage, Postgres, Redis, basically a pub subsystem, SQL Server, and then blob storage, basically Azure equivalent of S3. So now that I have this list of things that I can use in my app, the next step that I actually also already did was to create an instance. And the instance is the declarative resource that I can tell Service Broker, that I can submit to Service Broker, that is, to tell it to provision an instance. So what I've done is already submitted the instance to tell Service Broker to provision me a new Postgres, a Postgres database. So let me show that. So now you'll notice that the broker here and the service class here did not have a namespace. And that implies, of course, that they are available in the entire cluster. And that's by design. We want entire clusters to have access to the catalog of services. And then from there, we have some ACLs that allow operators of the cluster to decide which namespaces can get access to which parts of the catalog. So now I'm going to clear the screen. And we can see now we have two instances. This one I actually did as a test on Friday, and then this one I just did about 25 minutes ago to create the instance. The instance was created, and I will show some detail for this instance. Oops. Let's show it out in YAML. And you can see now this is the entire YAML of the instance. It's fairly straightforward. It probably would look familiar if you have seen pretty much any other Kubernetes resource. If I scroll down here, we can see in the status field, we have these fields that basically deal with asynchronous operations. So here's one called async op in progress. When I first submitted the instance, this thing was true. And what that meant was the instance of the Postgres was in progress of being created. So behind the scenes, we create quite a bit of infrastructure in Azure. So we create a new server, a few other things, a couple of rules, and then finally we create the new database inside of Postgres. So for about 10-ish minutes after I had originally created the instance, this was true. And there was a condition in here saying the instance is being asynchronously provisioned. And that was all done behind the scenes. All that I saw in the instance was it's being asynchronously provisioned. And then finally, after all of the operations were done in the broker, my controller, the controller inside of Service Catalog, ended up just continuously polling the broker And when the broker finally reported that everything was done, then this message said what it says now, and the reason says provision successfully, everything is ready, the status is true, and we're all good to go. So programmatically, if you were talking to service broker, you would wait for status is true and type equals ready. And that's how you would know that, okay, now my application is ready to start binding to this. And what binding means, as I'll show in a second, is create credentials and indicate to both the broker and to the operator of the Kubernetes cluster, whoever that may be, that your application intends to use that that Postgres instance on Azure. So let's show creating a binding now. Actually, I don't need the namespace. And again, I need to put the context in there. Okay, so let's see what happened there. So you can see here, again, fairly straightforward manifest that you're probably familiar with. If we go down to the status, we have something that looks a little bit like what we saw in the instance. We can see injected bind result, status is true. And if we go up here, we can see that there's a field called a secret name. So what secret name is it is what we use to tell Service Catalog where it should put the credentials for the database that it got back. And then additionally, right above the secret name, we have this name, this thing that references an instance. And that's what we use to tell Service Catalog what is the instance to which I want to bind. So as you remember, I created an instance of Postgres called my-postgres1. And this is what we're using to tell Service Catalog what we want to bind to. So I want to bind to that instance I just created. And then I want to write the credentials that I got back from the Azure broker out to this secret. So let's check out what that secret looks like. So there we have it. We've got a username, a password, a FQDN, a server name, a database name, and we can use all this stuff if we mount our application to we mount the secret into our application. And then as long as our application speaks SQL and can connect to a Postgres database, and of course it mounts the secret, it can use Postgres just as it would use any other Postgres, whether it was a Postgres in the cluster that was basically used the container file system, or if it was some other SaaS platform or provided outside of the cluster by your operations team on bare metal. And that's really where the power lies here. So as a side note, I'll trust that you guys aren't going to copy down this base64 stuff and decode it and start filling up my Azure database. Please don't do that. But essentially, that's the power of this Service Catalog system, is that let's say that I am doing development right now, and I've mounted a pretty cheap or maybe even free tier Postgres server. But I can use the exact same manifest that I showed, that I did the provision operation with the instance and I did the bind operation with the binding. And when I decide to go to production, I can submit the exact same manifest, but behind the scenes, that production cluster may be configured to use a completely different broker, or maybe the same broker but a different tier that is more appropriate for production. And the app can act the same. It can just mount that secret of the same name. It will expect that the same keys are in the secret. And as long as it can use those keys to connect to a Postgres server, everything else will be ready to go for it. So this, in effect, kind of takes away the complicated DBA and credentials passing, the kind of informal credentials passing that you might have had before. And it also now adds in, due to the presence of a binding and an instance, it adds in a little bit of an audit trail, because we not only can see that the binding and instance are there, and they're connected to an individual application. But we can also consume the events, the event log for all of those resources, and kind of have an audit trail of what happened as well. So with that, let me go back to the rest of my slides here. There's not a whole lot more of those, but just a couple notes on Service Catalog. We are in alpha quality. I'll provide these slides so you can check out all these links. I would encourage you to go check out that demo for sure, and that's the bottom link. But the exciting piece here is that we're going to be going even faster. We'll be out of alpha soon. We're going to be accelerating our momentum, or accelerating our velocity, I should say, once 1.7 comes along. Because as I said, aggregated APIs will really enable us to provide a way more seamless experience for this whole thing. Because we can then put instances and bindings, like I just showed, into Helm charts. And once they're in Helm charts, you can effectively bundle your application together with all of its service dependencies. And there's the self-documenting that happens at that point. So if you look at a chart and you see all of the instances in that chart, you can easily tell right away exactly what services that application requires. And that's a super powerful thing. So with that, let me close down these slides again and stop sharing. And I'd love to take some questions if you guys have any.
Aaron, can you unbind just to show them that the secret disappears? And they'll have to take our word for it that the broker revokes the credentials.
Yeah, sure. Let me share again and go back to the terminal. And again, we call familiar kubectl delete. What have I done? Wrong name. And I also have to specify the resource type. What have I done wrong? Okay, delete binding. And I forgot an equal
options. Your option was malformed.
There we go. So let's look at our binding again, make sure it's really gone. You can see that the binding is gone. And now what we would of course expect is that because the binding is gone, we would expect, like Kent mentioned, that the service catalog made a request to the backing Meta Azure Service Broker to do the unbind operation. And then additionally, since the credentials would have been invalid after the unbind operation happened, the service catalog should have deleted the secret as well. So let's make sure that happened. And that in fact did happen. So after the unbind has happened, the application that was using that secret with the Postgres credentials in it should, of course, now no longer be able to consume that secret, or at least new application, new pods that launch expecting that secret will now no longer be able to launch. And of course, that's a good thing, right? Because the Postgres no longer exists. So the whole life cycle of the create and update and remove is handled in a Kubernetes native way, just because we're using Kubernetes familiar resources here. So with that, I'm going to stop sharing again. And I know there's a bunch of chat. So if someone asks questions, if you could repeat them verbally, that would be greatly appreciated.
Any questions for Aaron?
Well, I'll grab one of them from chat and read it. This is, what is the relationship between Meta Azure Service Broker and Meta Azure Service Broker Helm, other than just the trailing Helm?
That is a great question. So I am terrible at naming. And the repo that I showed, which I'll paste into chat right now, do that. That is just a very, very poorly named repo that contains the demo, all the instructions for the demo, all the resources, everything else for what I just showed. So the relationship is Meta Azure Service Broker is the Open Service Broker API, and Meta Azure Service Broker Helm is the demo that I just showed. And thanks, Steve, for also posting in the Service Broker. And that is the GitHub repository for the big the big Cloud Foundry Open Service Broker API compatible service broker that was used in the demo.
Hey, Aaron, I have a quick question. I was curious in your demo why the binding didn't happen, or why you didn't create the binding automatically as part of the provisioning step, like, or not automatically. I know I understand why they have to be two separate steps, but for like the workflow, I was curious to know why you didn't have them together. And then later you had explained, you know, you might want to use a different type of instance for a more like production ready environment. Is that the reason why you don't put them together, or is there more to that?
There's a little more. So one piece is, as I mentioned, in 1.7 and beyond, what would be really helpful, and what we will definitely suggest at least, is that a binding and an instance go in the same Helm chart. But another thing is, I think Kent mentioned this in chat just now too, it is possible to create multiple bindings to a single instance. So effectively you can have one Postgres database and then multiple applications can use it. But yes, in many common cases, I won't say all, but many cases, you will create one binding for one instance. And in our beta, at least, we would say that it would be very useful to put those things in a single Helm chart so that the single Helm install will enable your app to talk to the Postgres or Redis or whatever else that it may require.
Awesome, thank you.
And Aaron, are we at the point now with Service Catalog where all of that will be eventually consistent, so that if you create the instance and the binding at the same time, the fulfillment of the binding will be deferred until the instance is provisioned?
Yeah, that's correct. So if you did a Helm install right now, what would happen is, of course, the application wouldn't launch because it wouldn't have the access to the secret. And the binding wouldn't work because the instance wouldn't have completed yet. But what the controller behind the scenes will do is it'll continue trying the bind. And of course, what the Kubernetes core controller will do is back off until the secret's ready. So the instance will complete first, and then the binding will complete, and then finally that secret will get written, and then the application will start.
Very cool. All right, thank you so much. We're gonna hold off on any other questions so we can move on to our next item. Let's go ahead and do the Kubernetes 1.7 updates if you're ready, Dan.
Yeah, so hopefully you can hear me now. Good, so 1.7, I added a couple of links into the notes. I mean, I guess the general status is that in 2 days on the 21st, we're planning to cut the release candidate, and the launch is still, the goal for the launch is still the week after that, so June 28th. So that's still what we're working towards. There's one link that has a list of all the open issues that need to be resolved before we can launch, and that's across all SIGs. I think as of this morning, there were 27. And then the second link is actually specific to SIG apps. And there were 3 last night, but people have cleared them out. There's only 1 remaining right now. So that's all that's left from, we're actually in pretty good shape from our SIG's perspective. Yeah, and this is down from there are about 100 or so open issues about a week ago. So all the SIGs have been working towards making sure that they close these out. So that's the list. If there's anything that you're aware of that's not on the list, like, let me know or create it and make sure that you tag it with milestone 1.7. But as far as we know, like that's everything that's remaining. So that's still on schedule. If there are any other questions, let me know. But as of right now, we're still working towards the same dates that we had originally planned. So it's still set for June 28th.
Okay, awesome, thank you. Janet, Ken, do y'all have anything to add? I'll take that as no. Thanks for the update, Dan. And
actually, yes, one thing, I was trying to be sure that, so there was one issue that got marked as 1.8, and someone just came through and marked it. Clayton has gone back and said it's important to have it in 1.7. So I think there's actually still 2 issues open for our SIG. I can link the other issue that's been removed. The PR is already open for it, so and approved. So it's basically just E2E testing for stateful set update, and we'd like to get that in for 1.7.
Okay,
Yeah, that's
awesome.
fine. Just make sure that it's tagged with the milestone 1.7 instead of 1.8, so that it shows up in all the reports. Thanks.
Oh, so that is the one issue. The issue is not currently tagged with the correct milestone. It was originally, but someone came through and tagged it with 1.8, I think, in order to just adjudicate it and resolve it. And I'd like to get it moved back to the correct milestone.
Okay, I'll get that done.
Okay, thanks.
Okay, and is there anything else you need from the SIG or someone, or I'm guessing every issue has an owner and there's an open pull request, but if there's not.
Well, there is one other issue that I kind of wanted to bring up during this SIG and just kind of make sure everyone's aware of it and maybe talk about it a little bit, but we can discuss that after people have completed their demos and so forth, if that's okay with everyone.
Yeah, that works. Thank you. Okay, and let's see. Let's go into the next demo. If you have questions on 1.7, just reach out to Dan or ask in the chat since we're running a little bit behind. Okay, so the next demo is by Gareth. He's going to talk about some Kubernetes JSON schemas and testing Kubernetes config files. I think he's been doing some work behind the scenes there. So Gareth, take it away. Show us what you got.
Okay, can people hear me and see my screen?
Yes to both.
Excellent. So I've been thinking and wanting to build and building a bunch of developer tools around Kubernetes. And this sort of started down a path that I'm hopeful might be interesting to other people doing similar things. So people are probably familiar with the Open API spec. So basically all of Kubernetes is described in this one luckily auto-generated document. It's currently up to 56,000 lines of JSON, I just checked. So most people have probably not spent that much time actually manually reading it. One of the interesting bits in here is this definitions bit. This describes all of the types in Kubernetes, basically using a superset of JSON schema. So, for example, API groups have, they require a name and version and server address by client users. There's a description here about what it is. They have different properties. Properties have types. This is used internally to auto-generate clients and servers. So everything just works from a single set of definitions. You can also use this to auto-generate different types of clients, which I've done before. But I wanted to build things that didn't require existing clients. They didn't require a full Kubernetes client. They didn't require a server to be running. I just wanted the JSON schemas. So because there's actually a whole bunch of tools and libraries that just support JSON schema. For those that haven't seen JSON schema, it's just a way of basically doing what we just looked at, describing like the schema of some data in JSON. So between those two things, basically, like there's a load of JSON schema stuff inside the spec, but it's not really useful for just raw JSON schema tools. I wrote this somewhat hacky at the moment, but it seems pretty much work. Open API to JSON schema tool. That's out there. I'll show it working in a second, so it's not too interesting. And then in combination of that, that's the wrong one. In combination with that tool and a bash script, I've now got a repo up of different flavors of all of the JSON schemas for all of basically the last sort of like 2 major versions of Kubernetes. So I'll show why this is interesting in a moment, but if we dig in, we can have a look. That's how we were talking about bindings earlier. Here is the JSON schema for a binding. So far, so much JSON, but let's see that in action and why it's interesting. So all I'm doing there is I'm going to run the Open API to JSON schema tool. I'm going to point it at a URL. In this case, I'm just pointing it at GitHub master. That could be at your Kubernetes install at the API, basically at the URL that exposes the actual JSON, the Open API spec. I'm passing a standalone flag, which I'll go into details if people are interested, but otherwise, we can gloss over. So that's going to download the schema. It's going to parse it. It'll output a load of bits and pieces when it generates a load of files. This shouldn't take very long. For most users, you wouldn't have to run this, in that I've already run this for a whole bunch of versions and they're available on URLs on the internet. So you can either just download them for local usage or just actually point your tools straight at the URLs on GitHub. If that sort of thing appeals. I might put up a nice like proxy for that at some point, just so the URLs are a bit nicer and permanent. Give that a second. So. Come on. There we go. Right. So that created a schemas folder with a whole bunch of JSON files in. I've got a hello nginx.json. So basically, it's a typical config file for Kubernetes. In this case, in JSON rather than YAML. I'll come to that in a second, though. The reason I've done that is simply because the JSON schema standard sort of tool actually just supports JSON. There's not really a good reason for that, and it's easy to build something on top. So I've got a deployment described in, like a Kubernetes deployment described in that JSON file. I'm making the output slightly nicer with that -f. You can sort of ignore this. The JSON schema tool itself is pretty low level. And I'm going to point it at the specific schema for the thing I'm doing. So, and it didn't say anything because it turns out that schema file is valid. And what can we do? Yeah, specs have to have templates for deployments, otherwise they're not valid if memory serves. And that now errors up. So that's saying like, whoa, there's a validation problem. Bear in mind, you can do that with any type, albeit in JSON and just using the raw JSON schema tool. That's not that interesting. It's, as I said, pretty much low level, but that starts to enable us to do higher level things. I've got a lot of ideas, but here's sort of one I made a bit earlier. Let's see. So I've got a bunch of Kubernetes files in both actually YAML and in JSON, and in actually using JSONit, using the ksonit lib. And hopefully that's big enough. I've written some basically unit tests for those files. I'm using Python just as a, like, from an implementation point of view. Ultimately, there's about 20 lines behind the scenes. You can implement it in anything. I might try and build a proper unit testing library at some point. But here we're saying we're actually building like unit tests for our config files. For all of them, they're going to be validated, and that we're able to validate them on the fly because we have those schemas handy. I'm doing some other tests, and that's sort of out of scope really here. So let's see that actually working. Oh, everything passed. So let's break something. So I've set that to run whenever I change any of the config files. So hopefully that should check that failed. None is not type string. That's basically because, let's do, again, still failing. Replication controllers have a metadata name, but it has to be a string. Back to passing. So there's no, and again, like there's no sort of kubectl, there's no Kubernetes server. And in this case, I'm literally just using the schemas from master that I just generated. I could just point them at the URLs that I've got in that repository. I could also extend this to test, for example, this file against a number of different versions of Kubernetes. rather than just one. We've got schemas for all of them, and they vary slightly in different places. So will this YAML file work on like a 1.4 series as well as a 1.7 series? We could find out whether it would be valid. There's sort of lots of potential for building tools around this. And this is sort of like a unit testing type frameworky thing. But I've thought about also extending some of the editors. There's a whole bunch of JSON schema support in like things like VS Code. Like that would be an interesting thing to explore. There's schema store. If we can get the JSON schemas for Kubernetes into there, I think a bunch of editors will be able to give you immediate error feedback on invalid Kubernetes configs. I think doing validation tools for Helm, I showed briefly there some of the case on it validation bits pieces. I've got a Puppet module that generates Kubernetes configs, adding validation into there as well, sort of on my list of things to do. There's also the whole, like, because we have the schemas for all the different versions generated, you can basically, if we can do a clever diff, you can actually see the evolution of the types. Again, that's useful for like migration tools, migration checking. Feels like there's all sorts of like testing and validation bits that this might make a bit easier. And so I wanted to demo mainly just to sort of say, hey, I've done this. If anyone is interested, please have a look. Hopefully that was of interest.
Definitely, thank you. Does anybody have any questions? You had a few in the chat, so if you want to check those out,
Oh, look.
respond, it'd be awesome. Yeah, I agree, Matt. This would be very cool to add to the Helm linter.
Yeah.
And it'd be cool to use for testing before like a release, Kubernetes release on the main charts repository, so that we can anticipate things are going to break, and so we would have to do something beforehand.
Yeah. So the other thing as well is where there are examples. So there's obviously charts, but like lots of documentation has examples in. Are those examples still valid? The answer is no one has any idea, which probably means over time, no. Obviously, it's easy to add checks, again, that don't require anything else other than the schemas.
Yeah, we should definitely, I think there's a SIG docs. I don't know if it's the same thing as ContribX, but have you talked to them about it? Because we should.
Nope, not yet. Yeah, I say basically I've been mainly interested in building like towards the unit testing framework for things like KSONNET and other like generated type stuff. But the route to get there is very much via like providing these building blocks that are useful for other use cases. So yeah, like if anyone is interested in using them, let me know, because I've shipped the bits now. But yeah, like I think as well when related to like some of the service broker demo and like custom resources, if they're like you could totally regenerate the schemas for your own Kubernetes config if you have custom resources. I haven't tried that yet, but it should just work. There's also a Google Summer of Code project going on at CNCF around some other JSON schema related stuff that because I shipped this, that person got in touch, and I'm going to follow up on like whether that's anything.
Awesome, sounds good. You have some more comments in the chat, but we're going to move on to the next thing. So would you mind dropping your contact information in the notes in the meeting minutes?
Nope, I'll do that.
Okay, thank you. All right, so up next we have, I know it's something about defer containers. Let me pull up the agenda. All right, 3 simple use cases for defer containers. Who's up for that?
Hi, it's Dilip from Huawei. You're able to hear me?
Yep, we can hear you.
So I have a couple of slides to share. Let me share my screen. Okay, everybody could see my screen?
Yes.
Okay, super. So a little bit of history here. We proposed differ containers in 1.7, and we couldn't get it inside 1.7 roadmap because one of the things is that we didn't get consensus in the community about the design. Number two is that we couldn't bring up a proper discussion about the use cases. So here is my first attempt. We want to bring differ containers back in 1.8, and then we want to start it as early as possible because of the amount of work involved, because we are going to add a attribute in the core API of Kubernetes. We might end up doing a lot of examples and documentations apart from code, so this might need a lot of time. So we want to bring it to the community's attention as soon as possible. So differ containers are very similar to init containers. For people who do not know init containers, here is an example I would like to show. So init containers have now graduated to the actual pod spec, but this is the previous example which I've tried. So you would be able to run a bunch of containers before actually starting your app containers in the pod. So this proposal is very similar to init containers. So this is how it is going to look. The initial version is going to be in a part of annotations, and it would be alpha. So you would have a sequence of containers that you could execute during the termination grace period. So that's the whole proposal. So let me start my slide here. So I want to start with the termination grace period. I feel that there is a scope of improvement in termination grace period in Kubernetes. I mean, in the real world, termination grace period is, I mean, a grace period is nothing but an extension of the deadline, right? I mean, in the real world, you would probably have banks giving you additional few dates if you miss your due for that month, maybe a credit card due or something. Say the bank gives you like 5 days of grace period, but you end up paying the bank on the second day. The rest of the 3 days are not counted. I mean, nobody's keeping track of the rest of the 3 days. So grace period is something that you would like to achieve your goal as soon as possible after the extension in the deadline. That's the whole point. The other computing example is that you try and take a log on a mutex or a semaphore, and then you try for 5 seconds, but if you could get a log in the first or second second, you wouldn't be waiting for it anymore. Unfortunately, from whatever I've experimented, pre-stop hook definitely waits for the entire grace period. Even if you could even if it could complete the process, the termination or the cleanup process, long before the actual grace period time. So that's one thing. I mean, that is a kind of problem, especially when you have stateful applications. There are some applications which might need cleanup, and those cleanup, the time taken for those cleanup will be very hard to predict beforehand, especially when these cleanups include network file transfer or a lot of disk writes. So these things depend on the infrastructure. So we should be able to provide the termination grace period, graciously, like 60 seconds or 70 seconds, even though the cleanup steps could be, we expect the cleanup steps to get completed in few seconds. Just to be safer, we should be able to give a longer grace period. And then if the cleanup completes before, we should be able to wrap up the actual application itself. So I want to present 3 simple use cases, which I believe is only possible to achieve using something like differ containers, and which is not possible to implement using pre-stop hooks. So the first use case is stateful applications such as DB or in-memory. 2 sub-use cases that, either you have to do a slave promotion during the termination, or you have to do a rebalancing of your shard. I mean, if your application is a sharded application, then if you're terminating, you will have to rebalancing of the keys. The other one is performing a graceful termination for a multi-container pods. Most of the pods which has got multiple containers, you are only bothered about the main container, but if the sidecar container also has some sequence, and that needs to be coordinated with the other containers, then it's very difficult with pre-stop hooks. And finally, this would nicely give us initialization and termination abstraction, especially for the higher level KTS controllers or operators in the future. So very simple illustration. Imagine a stateful set with 4 replicas, and because of a lot of re-elections, the replica 3 is now the master. So 3 things can happen to this stateful set, especially the final replica, the replica at the last ordinal index. Either it can get an update request, or it could be scaled out, or it could be evicted out because there is a better eligible pod qualified for that node. So in the three cases, once the pod reaches a state of termination, and it is trying to execute during the termination grace period, it can do two things. One is slave promotion. The other one is rebalancing. If it's a sharded application, it might do rebalancing of the keys. If it's a master slave type of application, it would try and find the eligible master before leaving. So in the sharded application, again, you would not be knowing how long it would take to rebalance. Point number one. It depends on the application state. For example, if your Redis cache has been running for months, it might have a few gigabytes of data. But in your test environments, the Redis could have only a few megabytes of data. So rebalancing a few megabytes would take just a couple of seconds, but rebalancing like a couple of gigabytes could take a longer time. So again, you should be able to predict, you should be able to give a graciously long grace period. So that's point number one. And if you had to do both, like, do master slave promotion as well as rebalancing the keys, it is still not possible using pre-stop hooks. The other use case is multi-container, which is very applicable only for stateful applications. But it might be there might be some use cases in the other areas as well. So here, the use case I could think of is that a primary application, and we have two sidecar applications. We could see a lot of we could see the trends going towards people building applications like this. The primary application just focused on its core values, and then we have sidecars for performing membership, and we have another sidecar performing active and slave switches, or leader and slave switches. So this thing is like this type of design pattern is becoming pretty common. So if this is the pod, then terminating this pod might have some sequence. For instance, you would first need to ask the primary application to stop accepting new client connections, and then you should probably perform active passive switch. You should probably make the application passive from being active if it is active, and then you should revoke the membership of this pod with its peers, and then you should wait until all these client connections or existing client connections are being served, and then you should go ahead and shut down the application. So these things involve cooperation of termination scripts among the containers. So you couldn't possibly do this with pre-stop hooks, because pre-stop hooks would be started in parallel for all these containers, and then it would be very hard for you to perform such cooperating tasks once they have been started. And finally, the use case is abstraction. Abstraction, we already have a nice layer of abstraction for initialization, and defer containers would bring the same functionality for termination too. So if you have a requirement for running arbitrary client code, and then you have your own initialization and termination scripts to be inserted without disturbing the customer's code, then you could use defer containers and init containers. Some of the examples here are like, you want to start billing and then stop billing. Start billing as soon as the containers are started, and then stop billing as soon as the containers are being stopped. So that could be easily achieved without touching the containers, customers' container images, etc. If you're writing a test framework or an operator to run a lot of test or CI systems, then you could easily initialize the test using init containers and then upload the test results in defer containers without knowing anything about the runtime of the test containers. Similarly, if you're building an operator for serverless type of workload, you might have a lot of runtimes for the serverless functions. So without writing termination scripts for each serverless runtimes, you could have a generic startup, initialization, and termination code using init and defer containers. So you could simply say that this particular runtime is not there anymore. So you could say that there is a runtime now for Python to the central controller. Then once the functions are executed, these runtimes are typically made to wait for a particular timeout, and then they just go and die. And then by the time they die, you can again inform the central controller that this runtime no longer exists. So finally, you could also use it in federated controllers, where before you start a particular pod using the federated controller, you could add a global DNS, which is different from the local DNS. And then when these spots are gracefully getting terminated, you could nicely remove these federated DNS entries from them as well. Even if the customer code has their own initialization and termination semantics, you could easily insert our own on top of that. You could add our initialization as the first one, and then add our cleanup at the last one, and then simply increment the termination grace period depending on the needs. So the behavior of the different containers would be that by default, it would be a pre-stop trigger, just like pre-stop hook. And then the restart policies, just to avoid confusion, the behavior would be that it would be restarted every time it failed. If you have configured a different container as well as pre-stop hooks in your pod spec, then a different containers takes precedence and pre-stop hooks are disabled. And then images, if there are any, for the different containers that are different from the application containers, they would be parallelly pulled when the application is running. With different containers, you will be able to get the logs, and different containers would survive Kubernetes restarts. And yeah, different containers, as we mentioned before, different containers would go ahead and kill the application if the cleanup finished long before the actual termination grace period. And yes, if a particular different container step is not completed, we would try as much as possible during the termination grace period. So if the pod is four-scaled, we will not run different containers at all. So finally, simple comparison with all the functionalities that different containers would bring in, and that is not available in pre-stop hooks. This one alone, I think there is an open PR right now. This might this might be added to pre-stop hooks, but everything else is still true as of today. So that's it. There is an open PR, a work in progress PR. We have implemented the initial minimal viable different containers for on top of the master. So people are welcome to try it and then give us feedback. And we would be happy to know what is the next step to bring this into 1.8 roadmap. That's it from my side.
I didn't catch that. Did you say you have a design proposal already?
Yes, we have a design proposal already. I think there is some discrepancy from what we have implemented in the work in progress PR and the design proposal. So I would go ahead and update the design proposal sometime this week.
Okay, cool. I'm interested in taking a look at that. That sounds interesting. Does anybody have any questions for Dilip? Okay, if you could paste a link to that design proposal on the docs, that'd be great.
Okay, will do. Thank you.
All right, so it's 1, but if you could just hold on for another minute. We should start on the 1.8 planning. Dan, I'll touch base with you on how we should go about doing that now that we have the PM leads and all that. And we can start that in the next week or so since we don't have time today, and that's totally fine. Other than that, I don't have any other announcements. Does anyone have any last minute announcements they'd like to make?
I have one quick thing. Well, actually, we probably should spend some more time talking about it. Because Helm does client-side validation, and I don't see that there's a way to turn it off, if I use even the newest release of Helm against Kubernetes 1.7, I can't set a non-root user if I'm going to mount volumes. Basically, pod security context doesn't work because of a wire-compatible but non-schema compatible change that was made in 1.6 to 1.7. And for a lot of the stateful application charts, anything that's going to run as a non-root user, which probably should be everything, it's not going to work against Kubernetes 1.7. So there are some options in terms of ways we could potentially address it. Long term, it seems like what the community is going with is we shouldn't be doing client-side validation. We should expect server-side validation. And if we do client-side validation, at a minimum, like kubectl, we should provide an override capability where you can bypass it. Because right now, there's no way for me to get these Helm charts to launch.
Gotcha. Do you have an issue open by any chance?
There's an issue that I just posted in chat, and I can add it to the doc. And there's been some discussion, but I haven't gotten a lot of participation from, other than from Andrew, from the charts maintainers and the Helm people. So I'd really like to get participation from you guys.
Okay, yeah. Since people are dropping off, is it all right if we bump that to next week's conversation?
It is. I mean, I was just trying to see if we could get something, if we could get to resolution fast enough where we could resolve the issue prior to the 1.7 release so that when 1.7 even beta goes out the door, the charts all still work. So.
Matt's asking if there's a issue in the Helm repo. I thought I heard you say there's one in the charts repo.
I believe Android has opened a referenced issue against the issue I just linked in the chat in the Helm repo as well.
Gotcha. All right. Cool. Thanks. We'll take a look at that. Does anybody have anything else? Okay. All right. We'll talk offline on the chat. And thanks everyone for coming today. And see y'all next week.